Hello everyone, continuing on our descriptive statistics. This time we're going to focus on mean, median and mode. A little recap. In the previous session on descriptive statistics, we were looking at the graphical summaries of the data set, where we found that pie charts and bar graphs best represented the categorical data. And also we could represent the quantitative data with the help of histograms, stem and leaf plots, or dot plots. Now we're going to focus on the numerical summaries of the data. Three things we'll be looking deeply into are the measures of center, measures of spread, and measures of location of a data set. For the measures of center of data, three topics will be looked at: mean, median, and mode. Also, we will look at the relationship between mean and median and see what kind of shapes our data set is telling us. Also, in the measures of spread, basically how far off the data set or the range of values are going about. We're going to look at standard deviation, variance, range, interquartile range. Look at the famous empirical rule for bell-shaped distributions, z-scores, that is standardizing a data set. And in measures of location, we're going to look at quartiles, percentiles, and median. And finally, we would look at the 5-number summaries, box plots, and outliers. So let's begin with measures of the center of data. Now, as said earlier, measures of center of data just simply says, how can we represent a data set by one single number? So it's a one-number description of the distribution or the distribution of the data set or the data set, whatever you want to call it, guys. The focus is going to be on mean, median, and mode for these quantitative variables. Let's begin with mean. Now, in a mean, it's just simply like what best represents a data set, an average value of the data set. It can also be thought of as the center of gravity. The numerical way of saying it is you add up all the elements in the data set and you divide by the number of the numbers. Now, here is how you represent or a formula for the mean. Now, what is the summation xi? Suppose we had 5 numbers. I'm going to give an example, and then I'll write it down in the proper form of the definition. Suppose I had 5 numbers, say 1, 3, 5, 2, and 1. I'd like to find the average of these numbers. So what we normally do is we will add them according to the formula. So this would be, so the mean for these numbers would be 1 plus 3, that's 4 plus 5, 9 plus 2, that's 11 plus 1, 12 divided by 5, because there are 5 numbers. So what do we get here? We get equals 12 by 5, which is going to be 2.4. Okay, that's an average. So what this summation notation means that suppose there were 10,000s of them. I'm not going to write each one of them. So what I'll say, hey, let one number be, say, x1. So this number would be, say, x1. Let the other number be, say, x2. Then x5, x3, x4, and there are 2 ones. One is x5, one is x1. So when I add them up, I'm simply saying x1 plus x2 plus x3. And then dot, 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 and then an xn. So when I want to represent them, it is going to be, say, x1 plus x2 plus x3 plus x4 plus x5. That's easy if there are only 5 numbers. But if there were so many of them, I would not write. So I would say x1 plus x2 plus x3 dot, 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 say xn. Now, how do I represent it in a very concise form? What we do is we say, okay, you see, x is the variable, but the variable which basically is changing is x is like common part, and the number which is changing is 1, 2, 3 is the subscript. So we say this is the variable which is changing I. Now I starts from 1, 2 and goes till 5. So what basically it means is you start with x1 because it's a summation symbol. The next element would be x2. You have add these two and you continue till you reach x5. Now if there are n of them, then you reply summation xi. I is the one variable which varies, and x is like just representing whatever numbers you want, and I goes from 1 to n, or simply summation xi I. Okay. Now that's simply the averages of finding a data set, which is one number which represents the whole data set. And it is simply add up all the numbers, divide by the number of numbers. Let's take an example. Your professor loves tea. Yes, I'm a tea fan, by the way, guys. So for 10 days, your professor kept a track of how many cups of tea she's having every day. The results are given below. We like to find an average cup of tea your professor is having. So what we do is we have 3, 2, 0, 3, 4, 1, 2, 3, 1, 3. According to the formula, you add up all the numbers. That's basically these cups of days, and then you divide their 10 days she looked at it. So you add this, you get 2.2. Okay. Now suppose you had an example where there was a frequency table. In other words, you had two columns, and one was the frequency and the other was representing the values. Now in that scenario, what are we going to do? How do we do it? So to find the mean of a grouped frequency table, this is the formula. Now this is an example here. This frequency table is representing the last statistics text grades of one of our classes. The grade interval goes from 50 to 56.5 until 98.5, and these were the number of students who got the grades in that interval. Now, if I want to find out the mean of this, it's not going to be easy, because how do I work with this grade interval? So what we normally do is, we try, instead of writing an interval, we will write it down as say one value. We will take the average of a midpoint of this interval. So in order to take, so we will say x higher, this is the midpoint. So we will do is 50 plus 56.5. So midpoint comes out to be 53.25. So that's what we will do for all the values. Then the other one would be 59.5. The midpoint is basically you add these two, divide by 2, and that's how you go by. And then according to the formula, you multiply 1 with 53.25, 0 with 59.5, and so it goes on. And then you divide by the sum. In other words, you add up these number of students, which comes out to be 19 here. So which I've done the work here in the next slide for you. Now, this is pretty cumbersome, right? Lot of work. I don't want to do it. Is there an easy way? Yes, calculators. Okay, so I'm going to show you how to do it with the calculator. What we do is, let's go back to the table. Okay, first of all, let's write down these terms. 59.5, this is 65.5, then 71.5, 77.5, 83.5, 89.5, and 95.5. Okay, this will be my first column, remember. So this one is L1, and number of students would be in L2. So let's get our calculators. What we're going to do is, we are going to go on second, and we should have just clicked on stats. I'm sorry, click on stats, edit, press enter. Now there are already some values. You want to remove these values. So what you do is you take your cursor. It's already at L2. Take it up, L2, clear, enter. Then take it to L1 on the top, and then click clear, enter. Now what you're going to do is, you are going to write down the values. Now remember, the values were 53.25. So it's 53.25 then enter, 59.5, enter, 65.5, enter, 71.5, enter, 77.5, enter, 83.5, enter, 89.5, enter, 95.5, enter. Now in L2 are all the frequency values. Take your cursor on L2. It is 1, enter, 0, enter, 4, enter, again 4, enter, then 2, enter, 3, enter, then 4, enter, and then 1, enter. Now we've got all the values. We need to find out the average of this. What are we going to do is we're going to go to click on stats, take the cursor to calc, one variable stat, enter, frequency list L1, list L1, frequency list L2, take the cursor now to calculate, press enter. Here's the answer. Notice the sum was 1460.25. The sample mean is 76.855. Notice that's exactly what you have here. Okay. Now, okay, so we have found the answer using calculators, which is much more easy than doing all this computational work by hand. Now let's look at median. Now median again is a one-number description of a data set, but here this is basically that value of the observation which divides the data set in two equal parts. And the steps are, first of all, we write down the observations from the lowest to the highest value. If the number of observations are odd, then the median is exactly the middle observation. But if the number of observations are even, the median is the average of two. So for example, if I have this number, say 1, 2, minus 1, 4, 5. So 5 values. So first thing is we are going to write it down in the lowest to the highest. So it's going to be minus 1, 1, 2, 4, and 5. Now as it's odd, the median value is right in the middle because it divides the data set in two parts. One side is minus 1 and 1, the other is 4 and 5. So I'm looking at all these values, guys. Okay, so 4 and 5, minus 1 and 1. Now suppose if the observations were even. Suppose I had 0, 1, minus 1, 2, 5, 3, and say 3. So the first thing we're going to do is we're going to write it down in the ascending order. So we start with first thing is minus 1, then we have 0, 1, 2, 3, 5. Now because these are even observations, so what we do is we look at the middle two. So the middle two over here, guys, is 1 and 2. Because this 2, so 1 and 2, notice, are the two values which divide the data set in exactly two parts. So you have minus 1 and 0, 1 here, and then 3 and 5 here. So what you're going to do is to find the middle observation, which is lying right in the middle of it. So that is, how do we find this one? We add the two terms next to that vertical line. So it's 1 plus 2 divided by 2, 3 divided by 2, 1.5. So here the median is 1.5. Okay, let's go back to your professor's example. As we said, your professor loves tea, 10 days she kept a record of it, and then we'd like to know what is the median cup of tea your professor has. Once again, we're going to write down the observations in ascending order as there are 10 of them, so to see where is the middle value. So 1, 2, 3, 4, so 2 and 3 are those two values of your drinking of cups, drinking tea of your professor which has 4 on the right hand side and 4 on the left hand side. So you take the median would be 2 plus 3 divided by 2, 2.5. So right here, so right in the middle, the median is 2.5. Okay, what's the meaning of mode? Now mode is basically that value which occurs the most in the data set. You can have more than multiple modes also. It's basically like clumps of data set or the highest bar on the histogram. This actually is much more valid and much more useful when you have categorical data. Okay, so for example, if I have this number, say 1, 2, 1, 1, 1, 5, 5. So notice by looking at it, it's 1 which is the one value which has happened the most. So the mode here is 1. Now let's take another example. Suppose I had 2, 2, 2, 1, 1, 1, 5, 6, 7. So here the mode category is 2. It's 2 and 1 because 2 has happened 3 times and 1 also happens 3 times. So the mode is 2 and 1. So you can have multiple modes, in other words. Okay, let's go back to your professor's example, guys. Now, as I said, your professor's loving tea. So 10 days she keeps a track of how many cups of tea she's having. Now we'd like to look at the mode for your cup for your professor. So clearly, how many times you see the number 3 actually pops up 4 times. So mode is 3. Now the question that comes up is, which measure is the best measure? Is it mean? Is it mode? Or is it median? Now before we actually can make some kind of a analysis on it, let's do some little bit more work. Let's see what is the relationship between mean and median. And which one do you think is going to be best for us? And that will help us which would be a good measure of center for us. Okay, so here's it. The shape of the distribution lets us know whether the mean is larger or smaller than the median. So there is very important relationship that if you have a symmetric or a bell-shaped curve, that means there's one single mound and it kind of, you can see that when you draw a vertical line from that peak of that little mound, you can see the mirror happening, that line, this vertical line is like the mirror image. The left-hand side is mirroring what is happening on the right-hand side. So this is the scenario where it's a bell-shaped curve, symmetric, mean is the same as median. But when you have tail ends, when you see one left-hand side or the right-hand side of the tail being pulled off your nice little, graphs here. What happens is when you have a right skewed distribution, you can think of this distribution as like, if you had, say my class did very well in one of the quizzes. So here is the value. So, I had this numbers like I had, say 10 tens. No, I think that won't be a good one. Let's talk about, say, salaries. I think that's a really good example for right skewed. So if you're looking at salaries of a big company, the salaries, average salaries for most of these people say are between 30K to say 50K. But the CEO of that company definitely is going to have, say, around, 3K or 5K. So in that scenario, what's going to happen is that bunch of the salaries, so this is like a salary scenario. So most of the salaries are, say, between this, but then because the CEO or the president is going to have a very huge salary, so this can be the CEO salary, but the bulk of the salary of the rest of the employees is over here. So this is like a scenario of a right skewed distribution. And what happens in the right skewed distribution is that the mean is going to be more than the median. On the other hand, if I had a left skewed distribution, that means the tail end on the left-hand side is being pulled to the left side. In this scenario, the mean is always less than the median. So in a skewed distribution is where you see either the mean is more or the mean is less than the median. In that sense, what you would also see graphically is that the mound is if it is right skewed, then the mound is more concentrated towards the left hand side of the graph. In this nice little curves we have. In a less skewed, the mound is more towards, most of the observations are on the right hand side and there are very few on the left hand side. But that's the one which is basically pulling up the left hand tail of this graph. Okay. So what we see over here is this. If we have a skewed distribution, the mean is further out in the long tail than the median. And whenever we have skewed distributions, we prefer to have medians. That's why that measure, median measure, is much more better when we have a skewed distributions. And those kind of measures are called resistant measures. Resistant measures means they are not sensitive to very extreme data which is present at the observations. So median is a resistant measure, whereas mean is not a resistant measure. Let's look at an example which will make it much more clearer. So here are the mean and median salaries of a company. So let's find out the mean of the salary. So the mean, we know as we add up all the elements, so it's 13,000 plus 32,000 plus 45,000 divided by 3, which is 13 and 32 is what? 45, 45, 45, so it's 90,000 divided by 3, 30,000. Okay. Now, also look at in this company X, the median is 32. Median and mean are very, very close to each other. Do you see that? So it's not going to be much of a difference when we create a graph over here. Whereas, for company Z, if the salaries here is 13, 32, and 250,000, big amount as compared to the other two. Now, median again is the same. So this is the median. But what about the mean, guys? So let's do the mean work. So mean is 13,000 plus 32,000 plus 45. Oh, no, it's not 45, guys. Plus 250,000 divided by 3. Roughly, the value comes out to be 98,333.3333. Now, clearly, this is the mean, is so far off from the median. Now, that is a sure shot. Even without even doing all the math, we could see that 250 is basically going to pull the whole graph. So if I want to draw a graph over here, so think of this one as this is 13 and say 32K, 1,000. Way out is 250. So when I draw amount, what is it? This is basically going to be a right skewed. On the other hand, when I look at these numbers here, so we have say 13, say 32, I can do a dot plot and or I can do just 2, so you have to say dot plot or whatever, and then 45. So when I just draw a nice little curve, I don't see any kind of being pulling on either side of the of the tail, of it left or right. Don't see that. So because here, notice this is the median. Where is the mean? Mean is very close to 32. That's 30,000, guys. So I'm just writing, I don't write all those triple zeros. Assume that's this 13K, 32K, and 45. So if you want to be very pedantic, you can write it down here and this. Okay, so this is like 13,000, 32,000, and 250,000. Okay. Do you see that over here, guys? Okay. So what we notice over here is that this 250 is like an anomaly, right? So this is basically like an outlier. So let's talk about outliers. So in the previous salary, as I said, 1332, so 250 is like the salary of a CEO of a company, and the rest are the normal salaries. This 250 is basically going to really pull away the graph. So this is an outlier. And outliers always lead to skewness in the distribution of the data set. One more example. According to statistics, Canada, in 2004, the median household income in Canada was 58,100. The mean was 76,100. So what can you say about the shape of the distribution? Notice median is 58,100, which is definitely less than the mean, which is 76,100. So what we have learned is if the median is less than the mean from our observations, this is right skewed distribution. Okay? Okay, let me write it much more nicer. It's, oh, oops, sorry. Okay. Okay. So here we just talked about numerical summaries, mean, median, and mode, and their relationships and how skewed distribution is related with the mean being either less or more than the median. Thank you.